We're going to introduce Laplace transforms today. The Laplace transform of a function f of t is an integral. It's a definite integral. And that integral is the integral between 0 and infinity of e to the minus st times f of t with respect to t. What that means, take the function that you have, multiply it by e to the minus st, and integrate it from 0 to infinity. The result that you will get will be some function of that letter s. S is only a parameter. It's a parameter that we use for a tool, and we control that s. We're going to get an improper integral. As long as it's doable, we do control it. So for example, if somebody asks you to find the transform of e to the power 4t, so what do? You put e to the power 4t inside the integrand, multiply it by e to the minus st, and then integrate. So let's see. The Laplace transform of e to the 4t is the integral of e to the minus st times e to the 4t dt between 0 and infinity. Let's combine these two exponentials. So that gives you e to the minus parentheses s minus 4t dt. Whenever you're integrating e to the power alpha t with respect to t, the integral is e to the power alpha t over alpha, what's in front of the t. Why? Because the derivative of alpha t is alpha. So for example, if you're integrating e to the power 8t dt, this will be e to the power 8t over 8 plus a constant, but we don't need a constant. So the integral of this can be obtained by thinking of this as alpha. Alpha would be minus parentheses s minus 4. So the integral is e to the minus s minus 4t over minus parentheses s minus 4. Let us substitute infinity for t, and when you do, e to the minus infinity is 0 minus, then substitute 0 for t. E to the 0 is 1, so that's 1 over minus s minus 4. The minus is cancelled, and you will end up with 1 over s minus 4. And that's the answer. This is the Laplace transform of e to the power 4t. We can generalize this for any function, any exponential that looks like this. Laplace transform of e to the power at is going to be 1 over s minus a. Here are some other transforms. The transform of sine kt can also be obtained by integrating, and you will end up with k over s squared plus k squared. K can be anything. And the transform of cosine kt is s over s squared plus k squared. So for example, what's the transform of sine 2t? Well, in this case, k is 2. So it'll be 2 over s squared plus 2 squared, which is 2 over s squared plus 4. And the transform of cosine 2t is s over s squared plus 4. Another transform is the Laplace transform of t to the power n. T to the power n, its transform is n factorial over s to the power n plus 1. So for example, the transform of t cubed would be 3 factorial over s to the power 4. Okay, 3 factorial is 3 times 2 times 1, which is 6 over s to the power 4. In this example, the transform of sine 2t is 2 over s squared plus 4. So, and the transform of cosine 2t is s over s squared plus 4. So s over s squared plus 4 is the Laplace transform of cosine 2t. We say that cosine 2t is the inverse Laplace transform of s over s squared plus 4. So if this is the transform of this function, then this function is the inverse transform of this function. Cosine 2t is the inverse Laplace transform of s over s squared plus 4. And the notation for inverse is this. Inverse transform of s over s squared plus 4 is cosine 2t. So if I wanted the inverse transform of 6 over s to the 4th, we did the transform earlier. That was the transform of t cubed. So that would be t cubed. What if we wanted the inverse transform of this function, s minus 4 over s squared plus 16? What we need to do is simplify it, break it up, do anything to simplify it. So we're going to separate these two terms. We'll write the s alone and the minus 4 alone. So s over s squared plus 16 minus inverse transform of 4 over s squared plus 16. Okay, s over s squared plus 16 has the form of a cosine, where k squared is 16, so k is 4. So this would be cosine 4t. 4 over s squared plus 16 has the form of k over s squared plus k squared, where k squared is 16. So this is the sine of 40. So this would be the inverse transform of this function. What if the numbers didn't work out? If they didn't work out, then we have to make them. This is what we do. Here's an example. The transform of 2 over s minus 6 plus 3s minus 4 over s squared plus 9 is an example. Okay. Here I'm going to take the 2 outside, so this will be 2 times 1 over s minus 6 plus 3 times s over s squared plus 9 minus 4 over 1 times 1 over s squared plus 9. And we still need to invert transform. So the next step is 2 times 1 over s minus 6 plus 3 times this function. Okay, for s squared plus 9, k squared is equal to 9, so k is equal to 3. So we would like to have a 3 in the numerator here. I took the 4 out, I haven't changed anything, so I'm going to put the 3 here, but divide by 3. So this would be 2. This is the inverse transform of This is the inverse transform of 1 over s minus 6. Why? Because the transform of e to the power 6t is 1 over s minus 6. So the inverse transform of 1 over s minus 6 is e to the 6t. So we're done with that part. Plus 3. This is the form for the cosine of 3t. So 3 cos 3t. And then this one here would be minus 4/3 times this part here would be sine, because you have k squared here and you have k here. So this would be sine 3t. And this whole thing is the inverse transform of the given transform.